All right, section 6.3 is called nonlinear systems of equations. Remember, a system of equations, we're looking at more than one equation at the same time, and we're trying to figure out what points they share in common if you were to graph them. We've been doing this with lines, but now we're going to do it with nonlinear systems. That means they're not lines anymore. Look at our first picture. See a parabola and a line? I want to turn back, and you don't have to turn there. I'm just going to turn back to the very beginning of this lesson where we looked at what a consistent system was. A consistent system are what 90% of your problems are, right? There's at least one solution. And I don't know if that seemed curious to you at the time if you read that. At least one insinuates that there could be more than one. But we were just looking at linear at the time. And can't linear systems only have one solution? A line can't turn around and come back and meet another line in two different places. So we, for all practical purposes in 6.1 and 6.2, we were looking for the one point that they shared in common. But they're consistent if they have at least one, they can have more. And that's what's going to happen today. We are going to have more than one point that they share in common because we are leaving lines. I would hope that you could look at this equation and go, oh, the x is squared, the y is not. This is a quadratic equation. It makes a parabola, and they've drawn it for you. And I really hope that you could look at this and go, they're both first degree. This makes a line. Do you see where a line and a parabola are, when they're consistent, are going to sometimes have 2 points that they share in common? We're going to be looking for both of those today. All right, just flipping back, just for the sake of flipping back, there were also inconsistent systems that share no points in common. They're parallel lines were inconsistent. Here, you could have a line and a parabola be inconsistent. What if you went to go graph them and your line ended up down here and never touched the parabola? Isn't that a possibility? So these could be inconsistent as well and share no points in common. It could share 1 point in common. Do y'all kind of remember in geometry the word tangent? What if this just kind of scraped by and just touched, right here, if you had a line? So there might be only 1 point sometimes, but that would still be consistent. Anyway, those are our options. But most of the time, 90% of the time, I'm looking for the 2 points where a line would cross a parabola. How do we do this? Solve each nonlinear system using either substitution or addition. And this is the hardest part of the lesson, is figuring out how to solve it. Am I going to use substitution or am I going to use addition? I think we're going to look for the addition method first, and if that doesn't work, we'll use substitution. Remember, addition method is also known as elimination. Can you look over here and see if we added these together, if you could eliminate something immediately? Look at the y. If I added the left and the right, wouldn't these two y's cancel each other out and eliminate? So on this particular problem, I'm going to use the elimination method. And watch what happens. These are already opposite signs, and they have a leading coefficient of 1. We go to add, the y's are going to cancel. You can't combine anything else, they're not like terms, so we're going to bring it all down. 2x squared plus x plus 3 equals 6. I just added the left side and I added the right side. Now, we have an x squared term, we have an x term. This is a quadratic equation. You need to be able to recognize that this is a quadratic equation. We're going to solve it by either factoring, square root principle, complete the square, or the quadratic formula. You will always try factoring first, and I hope you remember that when you factor, you need to set this guy equal to 0. So subtract 6 from the top. We go to factor it, or we go to see if it factors. Is there a GCF? No. Bummer. We're going to have to split the middle. 2 times negative 3 is a negative 6. Are there factors of negative 6? That will give me a 1. a positive 1. How about negative 2 and positive 3? So I'm going to bring down my 2x squared. I'm going to split the middle term into minus 2x plus 3x. I'm going to bring down my minus 3 and my equals 0. All right, we've got 4 terms. We group the front two. They share a 2 in common and they share an x in common. That leaves an x minus 1. My back terms, they share a 3 in common, leaving an x minus 1. That tells me, hey, they factor. Yay, that's great, because they both have the x minus 1 that you can pull to the front, and the 2x plus 3, the leftovers, go in the back set of parentheses. All right, if this times this equals 0, then either this equals 0, and x would be a 1, or this equals 0. Guys, if you need to write it out, 2x plus 3 equals 0 and solve to get your signs right, do it. But wouldn't you subtract 3 from both sides and divide by 2 on both sides? The question we have to ask ourselves now is, what have we found? So many of you throw parentheses around this and say, yay, I found the point, I'm done. You have not found the point where the parabola and the line intersect. You found the x value for one of the points and the x value for the other point. These are your x's for both points. So let's go ahead and put 1 comma and negative 3 over 2 comma. You have found the x values for this point and this point. How do you find the y's? You take your x's and you plug it in either to this original equation or this original equation. Please tell me you have used the second one. It's so much easier. But the first one should work. I'm going to take my 1 and plug it in for x. We get a 5. The 5 goes with the 1. Please don't put the 5 anywhere. The 1 and the 5 are partners and match up together. Now I'm going to plug in the negative 3 over 2 and find its partner. Add 3 over 2 to both sides. I'll go ahead and put a 1 under my 6 because I need a common denominator when I add fractions. My common denominator is going to be a 2. If I change the 1 to a 2 by multiplying by 2, I have to change the 6 to a 12 because I'll multiply it by 2. My back fraction already had a denominator of 2, so we can leave it alone. 12 halves plus 3 halves is 15 over 2. And that goes with your negative 3 over 2. Are there questions so far? How did I know to use the elimination method? Your eye just needs to start being trained. Is there a way that I can get rid of either my x's or my y's? It will get easier with every problem that you do. Okay, moving down to the next one. I would not expect you to recognize this as a circle because it is not in the form that we learned a circle in. You know, with the x minus h squared plus y minus k squared equals r squared. So I would not expect you to recognize this, but I would expect you to recognize that this is a line. So we have a circle and we have a line. Normally, we will find the 2 points, but couldn't the line hit at one point or couldn't the line miss the circle altogether? Those are options. But this particular problem has graphed these equations for you, and there are 2 solutions. All right, so we have to figure out, am I going to use elimination or substitution? Can I eliminate an x squared and an x? No, they're not like terms. You cannot eliminate those. Same with the y squared and the y, you can't eliminate them. So elimination is not an option. We're going to have to use substitution. Substitution method says solve one of your equations for x or y. We look for the one that's by itself. Do you remember that from a couple of days ago? The x is all by itself. Let's go ahead and solve for the x. It's going to be the easiest variable to solve for. I'm going to add 2y to both sides. Now, if x is equal to 2y minus 3, the substitution method says, hey, if x is equal to this, can't we change the x in the other equation to 2y minus 3? This problem takes a lot of room, guys, so I'm going to start way up here. Here we go. Bring over the 3. Open parentheses. 2y minus 3, close parentheses, squared. We're going to bring over the plus 4y squared, and the equals 63. Some of you are still taking the squared and acting like it distributes. It does not distribute, but y'all are still making that mistake. This is a FOIL problem. It is 2y minus 3 times 2y minus 3. All right, here we go with the foiling. I'm going to bring this 3 down. And foiling, 2y times 2y is 4y squared. We'll get a minus 6y. We'll get another minus 6y. We'll get a plus 9. Then don't forget about this plus 4y squared that needs to come down. And the equals 63. To save us a step, because this problem already requires very many steps, do y'all see this minus 6y and this minus 6y? Can I combine those? I'm just going to go ahead, if it's just the same to you, and put minus 12y right there. If you can do that and be neat and I can follow, that is fine. Next, we have to distribute the 3. 3 times 4y squared is 12y squared. Then we're going to do the 3 times the negative 12y, give me a minus 36y. 3 times 9 plus 27. Bring down the plus 4y squared and equals 63. All right, I see some like terms. I see the 12y squared and the 4y squared. 12y squared plus 4y squared is 16y squared. Is there anyone who needs me to walk them through anything thus far? We're not close to being done. Y'all are okay? All right. Now that we've cleaned this up, as much as we can clean it up, I see a y squared and I see a y. This is a quadratic equation. To solve a quadratic equation, you have 4 options. I've asked you to see if it factors first. All right? To see if it factors, we need equals 0. We don't want equals 63. Subtract 63 from both sides. And 27 minus 63, I will be your human calculator, is a minus 36. All right, we're going to see if this factors, but step 1 in factoring is pull out a GCF. Let's make these numbers smaller. I certainly don't want to have to multiply these and see how about splitting the middle. 16 and 36, that's going to be huge. So let's go ahead and see what they share in common. A 2 for sure, but let's see if there's anything bigger. A 4. 8 goes into 16, but 8 does not go into 36. 9 goes into 36, but 9 does not go into 16. I think 4. 4 is as big as it gets. That'll help a little. Take a 4 out to the front. Okay, that's as far as it goes. We're going to have to split the middle. Multiply the 4 times the negative 9, and we get negative 36. Are there factors of 36 that will give me a 9? 1 in 36. Not going to do it. 2 and 18. Not going to do it. 3 and 12. Ding, ding, ding. 3 and 12. It is going to be a minus 12 and a plus 3. Those will multiply, give me the negative 36, but they will add to give me the negative 9. All right, I'm going to hold off on this 4. Guys, this 4 that's out front, it's going to come down later, but let's just deal with the factoring right now, okay? We will bring down the 4y squared. We will split the negative 9y into minus 12y plus 3y. All right, looking at these front terms, we've got a 4y that they share in common, which leaves a y minus 3. The back terms will share a 3 in common. Pull that to the front, and it leaves a y minus 3. Yay, it factors. Y minus 3 comes to the front. The 4y plus 3 that's left over goes in the back. We're going to bring down, at this point, we're going to bring down the equals 0, and at this point, we're going to bring down the 4. The 4 is of no consequence to the problem. It's just part of your factored answer. So it needs to be there. But when it comes to our final answers, it doesn't matter. If this times this equals 0, it doesn't matter that this is a 4. Either this has to be a 0 and y is 3. Or this has to be a 0. Write it out if you need to. You would subtract 3 from both sides and divide by 4. I wish that was our final answer. Look at all the work you've done. It's crazy. But unfortunately, that is not our final answer. That is the y coordinate of one of our points and the other y coordinate of the other point. So I'm going to go ahead and write something comma 3 and something comma negative 3/4. We have found the y's. How do I find the x's? You take your y and you either plug it in here and solve for x, but let's not do that. Let's look for something easier. We plug it in here. It wouldn't be too hard, but isn't this equation the same as this one? We just changed its look. So we can plug it into here, and that's going to be our easiest bet. You should get the same thing no matter where you plug it in. But my x is equal to 2 times my y. Let's do the 3 first. Minus 3. I plugged in this 3 for y. 2 times 3 is 6. 6 take away 3 is 3. When you plug in the 3 for y, you get a 3 for x. This goes with its partner. Do not put it in the other set of parentheses. It goes with 3. Now I'll plug in the negative 3/4. X is equal to 2 times negative 3/4 minus 3. Well, 2 times negative 3/4, that's going to be, you could cross reduce here and make your numbers smaller. I think I would recommend that. And then you get 1 times negative 3 and 1 times 2. If you got 6/4, that's fine. Do you notice that negative 6/4 reduced this to negative 3/2? All right. Right here, I need a common denominator. My common denominator will be 2. If I change the 1 to a 2, then I have to change the 3 to a 6 because times 2 times 2. Negative 3 halves take away 6 halves is negative 9 halves. There are the two solutions. The 2 points where the circle and the line intersect. That's a workout. Look at all the work. You should be proud of yourself. Okay. Are there any questions? Did anybody get lost? Yes.
Would it also work at the beginning step to use substitution, but can we also use elimination to square the second solution? Or
I haven't tried it. The question if you didn't hear it, is could you use the elimination method and square this? I think you have x, y's all in there, you know, because you would have an x, y term, and I just think it would get too messy. I kind of think that this is probably the best and only way to go about this. All right, well, let's turn to page 63 and do a couple more. The good news is 63 is easier than 62. So, okay. Looking up here, I would not expect you to know that this shape right here makes what looks like a hyperbola. I would not expect you to know that, but I would expect you to know that this makes a line. Okay, and so we are looking for, they've graphed them for you. This one is going to have two solutions. We're looking for the 2 points where they intersect. I say look for elimination first and see if it's possible to use elimination. Can you eliminate? I mean, we don't have like terms here. We don't have like terms here. It does not look like elimination is going to be a possibility. So we're going to go with substitution, which means you either have to solve this for x or y. That's going to be tough. Or solve this one for x or y. Ooh. I see this y all by itself. Let's solve this guy for y. We're going to subtract 2x from both sides. Don't forget to bring that down, that negative, with the y. Now divide everything by -1, and it will change all of your signs. If y is equal to 2x minus 5, can't we change the y up here to 2x minus 5? So we're going to bring over our x, open parentheses, 2x minus 5, close, plus 2 equals 0. Distribute the x, you'll get 2x squared minus 5x plus 2 equals 0. You should recognize this as a quadratic equation immediately. I want the alarm to go off in your head that says quadratic, quadratic, quadratic. Try to factor it. There's no GCF. So again, we're split in the middle a lot today, which is good practice. 2 times 2 is 4. Are there factors of 4 that will give me a minus 5 in the middle? 4 and 1, but both of them have to be negative, guys. That's the only way to add and get a minus 5, but to multiply and get a positive 4. I will bring down my 2x squared. I will split the middle into minus 4x minus 1x, and I'll bring down the plus 2. All right, now we group. Front terms have a 2x in common. That will leave an x minus 2. The back terms have nothing in common, but when you're grouping, you're going to take out what everything has in common, which is a 1. And because of the minus sign in the middle, it changes the sign in your back set of parentheses. That leaves me with x minus 2, 2x minus 1. If this times this equals 0, either this front one equals 0 and you get positive 2, or the back one equals 0, you would add 1 to both sides and divide by 2. Trust me then when I say that some of you are going to throw parentheses around this and call it your answer. That's why I keep emphasizing it. This is not your final answer. This is the x term for one of your solutions and the x term for the other solution. We need to plug in and get the y's. You can take your x's and plug them in here, or how about here? When you solve for one of your variables, that is the same equation as this one. They're the same, as long as you did it correctly. So I'm going to plug in my 2 right here. 2 times 2 is 4, take away 5 is negative 1. 2's partner is negative 1. Make sure you put it in the right set of parentheses. I'm going to plug in the 1/2 for x. 2 times 1/2 is 1. 1 take away 5 is negative 4. 1/2 partner is negative 4. That one's a little bit easier, I think, than the previous one. Agree? The last one's my favorite. We have 2 parabolas. It is almost impossible for me to find the exact point. I mean, it kind of looks like right here, but it could be right here. This one looks a little bit clearer, kind of right there, but it's still very difficult to find exactly where they meet. That's why doing this with algebra is a better way than doing it by graphing, because it's really hard to find the precise point where they meet, especially if you have fractions like in this top one. It'd be really hard. So we have 2 parabolas. I hope you can look and recognize when the x is squared and the y is not, you have a parabola. This one is my favorite because they've almost set it up for us. Do you see that they have y equals something and y equals something? If y equals this and y equals this, don't these things have to be equal to each other? They have to be equal to each other. So all we have to do is take these 2 equations and set them equal to each other. Which method is that? It's the substitution method. They've already solved the equations for y, so all I did was take what y was equal to and plug it into the other equation for y. That's all I did. It's the substitution method. But when you see y equals and y equals, you can drop the y's and set them equal to each other. And what's left is a quadratic equation. We need it equal to 0 because we want to look to see if it factors. So I'm going to move this stuff over here to get a 0 on the right. Two x squares take away an x squared leaves an x squared. 5x's take away 4 leaves still a positive x. Negative 11 take away 1 gives you a minus 12. The reason we set it equal to 0 was to see if it factors. There's no GCF. Leading coefficient's 1. Yay! It's finally, we don't have to split the middle. There are factors of negative 12 that will give me a positive 1. How about plus 4 and minus 3? If this times this equals 0, either this is 0 and x is a negative 4, or this is 0 and x would be a 3. My points are negative 4 comma something and 3 comma something. But we have to go get our y values. You take your x's and you plug it into either of the 2. I like the bottom one just because the numbers are smaller. So we're going to plug negative 4 in. And when you plug in a negative, you put parentheses around it or it's wrong, guys. It's wrong. Because it's a negative 4 times a negative 4, which is a positive 16. In the middle, I'll get a minus 16. 16 minus 16 is 0 plus 1, which is 1. The negative 4's partner is a 1. 3's partner, we plug in 3. I'm going to go ahead and put parentheses anyway, just because then I won't I won't forget. With the negative. 3 squared is 9. 4 times 3 is 12. 9 plus 12 is 21. Plus 1 is 22. 3's partner is a 22. There are the 2 points that these parabolas share in common. I promise you I would not have been able to locate them with the picture, even though they're not fractions. Picture makes it too hard. That's where the algebra comes into play. That is section 6.3.